Students, this is Dr. K. Shivaya, Department of Pharmacology, Faculty of Shantiram College of Pharmacy. So today we can discuss about urinary system, especially anatomy. Physiology we can discuss next class. So come to the introduction. Urinary system is a system. It consists of kidney, ureter, urinary bladder and urethra. You have to observe one point in any system. First we have to write urinary, any system we have to, is this system, it consists of whatever the in that system contains organs. So it is easy for remember any system. So that's why. So the urinary system also known as renal system. So the urinary system refers to the structures. The structures nothing but kidney, ureter, urinary bladder and urethra that produce urine to the point of excretion. So what are the organs? 2 kidneys, 2 ureters, urinary bladder and finally urethra. So these are the where it is located, the structure of urinary system. So this on the above the adrenal gland present. This is aorta, so coming from the heart. This is inferior vena cava, it is enter into the heart. So these are the ureters, these are the urinary bladder and urethra. You know, the kidney, come to the kidney, 2 pairs of kidneys present, one on left and one more right. In the kidney, the structural functional unit is a nephron. So urine is formed by nephrons. Come to the location. The location, if you take in location and external anatomy, it is present retroperitoneal cavity, or you simply we can call it as a peritoneal cavity. So where it is exact position, the peritoneal cavity, the vertebral column lateral. So this is present lateral into side. So lateral thoracic 12. So the this is vertebral column. The vertebral column exact it start T12. Thoracic vertebral column T12. So you know the thoracic vertebral columns are how many? 12. So exact here here it will start. This is a left kidney, this is a right kidney. So average kidney 12 centimeters height, 12 centimeters height, 6 centimeters wide and 2 to 3 centimeters thickness. So these kidneys protected by 3 connective tissues, that is renal fascia, adipose capsule or renal capsule. So the renal fascia attached to the abdominal wall. So I said that it is present in peritoneal cavity and abdomen. So both in between it is present. Next adipose capsule. So it is consists of fat. It is acts as a cushion any mechanical damage to protect it. And renal capsule, nothing but it is fibrous layer to protect from trauma and infections. So these 3 layers to protect the kidneys. It is not comes under structure. These renal fascia and renal adipose capsule not comes under structure. Renal capsule it is structure, but renal fascia it is outer layers only. Renal fascia and adipose capsule. See, this is the structure of kidney. The outer layer we can call as cortex, the inner layer we can call as medulla. The middle hilum means one hook, it's like just like chinna nokku lantidi, so that's we can call it hilum. This part we can call as renal sinuses. We can another images we can understand what is that. So this is up to here the renal cortex. So in medulla we have the renal papillae. So this the collectively we can call it, this is a small say knob like structure we can call it as papillae. So outer layer is with renal capsule, it is present. This is a minor calyx. So these renal papillae enter into the minor calyx, that minor calyx enter into the major calyx. This we can call as the entire the major calyx enter into the renal pelvis. This part between renal pelvis. Then come here renal pyramids. These are we can call as renal pyramids. So the here the nephron present, then it is enter into the renal minor calyx, then major calyx, then pelvis. See, this is the anatomy of kidney. So outer layer renal capsule, then followed by renal cortex, then renal medulla. In renal medulla we have the renal pyramids. That renal pyramids enter into the minor calyx, that minor calyx enter into the major calyx, that major calyx enter into the renal pelvis. So gross anatomy can again see the renal parenchyma and renal sinuses. So renal parenchyma has two zones, outer cortex and the medulla. See, again the same. So the difference, so this is original, this is diagrammatically. So this is medulla, how this is minor calyxes and minor calyxes make, then after that major calyx, then in between here this is the sinus. Here see what is that sinus. See that sinus consists of blood vessels. So wherever the these between the pyramids and calyx, between the pyramids and calyx, the blood vessels present, there it is sinus we can call. So simply up to here one pyramid you can, up to here we can call as a renal lobe. Renal lobe. Outer cortex and the inner medulla. The medulla consists of so I said that the renal medulla it is present in the medulla, that is 6 to 18 renal pyramids. The cortex come to the composite of roughly 1.2 millions of nephrons. See, this is the cortex. In that cortex only nephrons present. Finally it reached to the renal pyramids. So the cortex is composed of roughly how many millions? 1.25 million nephrons present. So the renal pyramids extensions of cortex. So what I said that these pyramids nothing but these extensions of cortex. These extensions make pyramid. So divided into 6 to 10 renal pyramids. Pyramid plus over cortex. So I said that this pyramid and this cortex. So these collectively enter into the this pyramid. So because of here present nephrons, these nephrons make pyramid. So these entire we can call as one lobe. We can write it as one lobe. That's why the pyramid plus overlaying cortex is called one lobe. So point of pyramid papillae. Point of pyramid papillae. So this point, they make one point that we can call as a papillae. That point enter into the minor calyx. 2 to 3 minor calyx then enter into the major calyx. 2 to 3 major calyx enter into the renal pelvis. The renal pelvis enter into the ureter. This is the way. So renal cells is surrounded by renal parenchyma, contains blood vessels, lymph vessels, nerves, urine collecting structures. Hilus. On concave surface, vessels and nerves enter and exit. So this is a hilum. This we can call hilum. In the hilum, this is concave. This is convex. So in the concave, this is a hilum. In the hilum, here the blood vessels or nerves enter. Blood vessels and nerves are enter. So that is the thing. On concave surface, vessels and nerves enter and exit. So major and minor calyxes along with the pelvis drain urine to the ureters. That is the thing. So again same the structure. So how the blood vessels enter. This is a renal artery and this is a renal vein. Then after that they are divided into subarteries. That's we can call it as interlobal artery and interlobular vein. So this is medulla. So come to the nephron. It is a structural functional unit of the kidney. How many is there? 1.2 million per kidney. Where it is present? Cortex. Where it is extended into the pyramids. They are present in cortex. They are extended into the pyramids. The three main parts: blood vessels, blood vessels present, renal corpuscles and renal tubules. These three the main parts of nephron. So nephron lo blood vessel untayi, corpuscle untundi. Corpuscle nothing but we can discuss renal glomerulus capsule. That's the entire it will come. We can discuss. Renal tubule means proximal, distal and collective ducts. So glomerulus. So here glomerulus, if it is taken, it is a capillaries. That capillaries filtration in glomerulus initiate urine production, filtrates lax cells and proteins drained by efferent arterial and pituitary capillaries renal vein. See, this is the entire part we can explain. I can explain here. So the renal artery, which artery enter into the glomerulus, then it makes divided to make small capillaries, then after that it leaves same artery that we can call as efferent. Which arteriole enter into the nephron, we can call it as efferent, which that same, that is the same, it will connected, then it is leave from the capsule, Bowman capsule, we can call it as a efferent arteriole. So they can filtrate. So they are made up of epithelial cells only, the capillaries. Arteriole then are further divided into blood capillaries. Everybody know. So renal corpuscle composed of glomerulus and the Bowman capsule. The renal corpuscle is the beginning of the nephron. This is the nephronian filtering component. So the glomerulus is a capillary tuft that receives its blood supply from the efferent arteriole of the renal circulation. The glomerulus blood pressure provides the driving force for water and solutes to filter out the blood. So with some force of blood, when it is enter, then automatically the filtered. So which are unfiltered, they can reach into the efferent arteriole, then again enter into the blood circulation. So that's the thing happening. So remaining blood spaces into the efferent arteriole. The diameter of the arteriole is smaller than that of efferent arteriole. This is the one of important bit also. The diameter of efferent arteriole is small. See, you can see once again what is that? This diameter very small when compared to the efferent arteriole. So E of ikkada mella small అవుతూ. So because of this, automatically what happened, the force increased here, and forcibly it is leave the blood. So it's the happening. So the diameter of efferent arteriole is smaller than the efferent arteriole, increasing the hydrostatic pressure. So you simply ఇప్పుడు పెద్ద పైప్ నుంచి చిన్న పైపులోకి వెళ్తుంటే ఆటోమేటిక్ ప్రెషర్ అనేది ఇంక్రీజ్ అవుతుంది. ఎవ్రీబడి నో. సో లైక్ దట్, సో హైడ్రోస్టాటిక్ ప్రెషర్ అనేది ఇంక్రీజ్ అవుతుంది. సో Bowman capsule. The Bowman capsule also called the glomerular capsule surrounds the glomerulus. You have to understand important renal corpuscle composed of renal corpuscle composed glomerulus, Bowman capsule. This is a renal capsule, nothing but this one. This is a renal capsule. Then Bowman capsule also glomerulus capsule surrounds the glomerulus. Nothing but the entire capillary is surrounded the one capsule. So it is composed of inner layer formed of specialized cells called as podocytes. So parietal outer layer composed of a simple squamous epithelium. So fluids from the blood in the glomerulus are filtered through the visceral layer of podocytes, resulting in the glomerular filtrate. The entire renal corpuscle, glomerulus plus corpuscle. So this is about renal corpuscle regarding note. So this entire part of renal corpuscle. This is afferent arteriole. Then this afferent arteriole, it is divided into small capillaries. These capillaries, then after that, see, this is the diameter is very high. Then after that, here if you observe the like small, finally inside it is not visible. So finally the diameter, if you observe the afferent arteriole diameter is, this is bigger, the efferent arteriole is smaller, then automatically the pressure is increased. Because of this, the filtration rate is more. So whatever the filtered, it is entered into the lumen of the proximal convoluted tubules. See, these podocytes, so it is covered by capsule. So these through these podocytes and capillary of the blood vessel, through these two, the filtered, these filtered enter into the lumen of the proximal convoluted tubule. This is a glomerular corpuscle parietal layer. These podocytes. So here filtered. So come to the renal tubular leads from glomerular capsules end at the tip of the medullary pyramids. So it is renal tubule 3 centimeters long. 4 major regions: proximal convoluted tubule, loop of Henle or nephron loop, distal convoluted tubule or collective duct. These are the next parts. So come here. This is proximal convoluted tubule, and this is a loop of Henle, and this is distal convoluted tubule. This is collecting ducts. So where it is present, see, I said that the nephron present in cortex, then they are extended into the medulla. They extend to the medulla. This is the outer medulla, this is inner medulla. So finally the distal convoluted present in cortex only, but finally the collecting duct, it reached to the inner medulla. So this is the how distributed, how it is located nephron in the kidney. So come to the proximal convoluted arises from the glomerular capsule. This is longest most coiled region, lies in cortex, lined with a simple cuboidal epithelium. It is made up of a simple cuboidal epithelium with brush borders which help to increase the area of absorption greatly. So it is the border is a little bit brush in nature because so folds because of this increase the surface and increase the more absorption. So nothing but prominent microvilli, the function in absorption. So like microvilli structures present in proximal convoluted tubules is the microvilli structures we can also observe in intestine, small intestine. Loop of Henle, it is a U-shaped loop. Say it's a hairpin like structure. So U-shaped distal tube. It is U-shaped. It is different to proximal convoluted tubules. Lies in medulla. Two parts, descending and ascending. So descending means decreasing, ascending means up, going up. So already discussed. Next, ascending limb and loop of Henle. So ascending divided into two segments. So lower end of ascending limb is very thin and is lined with a simple squamous epithelium. The distal portion of ascending limb is thick and is lined with a simple cuboidal epithelium. See, if you observe, so this is a descending loop of Henle, descending because of it is come down, that's why it is descending. So these are descending so this is regarding about ascending loop of Henle. Descending loop of Henle we can see it's not given. Okay, fine. So proximal convoluted descending loop of Henle, but we can observe that the major difference in ascending loop of Henle, the lower end of ascending is very thin and is a simple squamous epithelium. The distal portion of the ascending is thick and lined with simple cuboidal. Here simple squamous and this is a simple cuboidal. See where it is this one. This is a simple squamous. Then after this is a thick simple cuboidal. This region cuboidal. This is a simple squamous. That is the difference. The thick ascending limb loop of Henle enters cortex and becomes distal convoluted tubule. Thick segments active wherever the thick segments is there, the active transport of salts, high metabolism, many mitochondria presence. Thin segments permeable of water. So wherever the thin segments it is present, the more permeable of water and low metabolism. This is happening. Distal convoluted tubules. So here coiled distal to nephron loop, shorter than proximal convoluted tubule, less coiled than proximal convoluted tubule, very few microvilli. When compared to the proximal and distal, the very few microvilli. Contact afferent and efferent arteriole. So contact with the peritubular capillaries. This is the overall structure of how it is present. So this is Bowman capsule. It is present in cortex. Then come to this proximal. This is Bowman. Then after the proximal convoluted tubules, it is slowly enter into the medulla. Then after that again it is this is a proximal convoluted tubule here. Then after that a loop of Henle, then thick loop of Henle, then again distal convoluted tubule, then again the collecting duct here enter into the medulla. This is the how it is the location, the structure. Distal convoluted tubules of several nephrons empty into a collecting. So whatever the distal collecting tubules finally enter into the collecting duct, passes into medulla, several merge into papillary duct and drain into minor calyx. Then minor calyx enter into the major calyx. The major calyx enter into the pelvis. Then pelvis enter into the ureter. Then ureter enter into the urinary bladder. Then the urinary bladder to urethra. This is the way of next the ureters. So pairs of muscular tubes extend from the renal pelvis to the bladder. Oblique entry into the bladder prevents the backflow of urine. So these oblique, because of these oblique, the urine it's only enter into the bladder. There is no backflow movement. There is no backflow movement because of the oblique entry. So we can observe the how it is. So come to the ureter, we can observe the tissue what it is made, because transitional epithelium, the inner layer it is made transitional epithelium. Then in the middle layer it is 2 layers, inner longitudinal layer and outer circular, muscularis, the ureters. Then on out external layer it is a type of connective tissue. This is the ureter structure. So what is the main function? Carry the urine from the kidneys to urinary bladder via peristalsis movements. The peristalsis means contraction, relaxation, contraction. This is a rhythmic contraction of smooth muscle. So these are 2 layers, longitudinal and the outer circular muscle. They are automatically rhythmic contractions and takes place. Contraction, relaxation, contraction, relaxation. That is auto. Then to make one peristalsis movement, pressure from the full bladder compresses the ureter and prevents the backflow. See, when the urinary bladder full, that urinary bladder when it is full, that it makes pressure on the ureters, that compress the ureters. Then there is no backflow. Prevents the backflow because of a small diameter, easily obstructed or injured by kidney. This is regarding disease, it is not necessary now, so that's why I deleted. So urinary bladder, so is a collapsible muscular sac. Is a muscular sac to stores and expels the urine. Full bladders, spherical in nature, expand into the abdominal cavity. So where it is present? It is present in abdominal cavity. So empty bladder lies empty within the pelvis. So whatever the empty bladder if it is, so here the pelvis present. It is bone. So we can observe the layers wall of the bladder, because of transition epithelium, muscular detrusor muscles present, and tunica adventitia means it is made up of connective tissue. So wrinkles termed as wrinkles. So in that detrusor, so this is detrusor muscle. So in that, so this is entry of ureter openings. When the bladder full, then automatically when it is pressure, that ureters closed. This is a parietal peritoneum, and also we have the one muscle here, that is the detrusor muscle. So here the internal urethral sphincter, and here the external urethral sphincter. This is in female, that's why it is more length. If you observe in a male, it is a very the internal urethral sphincter and external urethral are very near. This is a trigone. It makes because of these 2 entries and one outgoing, the formed urine leave from the urinary bladder through through sphincter. So let's see one more hole is present. So if you take an urethra in male, 80 centimeters long in males, prostatic urethra, 2.4 centimeters long in bladder, prostate membrane urethra. Membrane urethra 0.5 centimeters passes through the floor of pelvic cavity. And penile urethra, see that urethra how it is divided. 80 centimeters long of in male's urethra, the prostate urethra. So here the near to the prostate gland, that's why it is about 2.4 centimeters. So that urethra near to the prostate gland, that's why it is given the prostatic urethra. Next, membranous urethra 0.5 passes through the floor of the pelvic cavity between the prostate gland and penile urethra. So it is very 0.5. Then penile urethra, so it is present in penis. So in that the penis is 15 centimeters long. So that's why the penile urethra 15 centimeters passes to the penis. So that is the thing. So this is the, so here this is the prostate gland, this is prostate gland urethra. This is this is 0.5 centimeters. That's why it is what you called membranous urethra. Next, this is penile urethra. It is present in penis. This is regarding anatomy of urinary system. Next, we can discuss about the physiology of urine formation next class. Thank you for watching. Subscribe it, make it notes, and once again watch videos slowly, concentrately, and do the work.